Hi, I'm Terry Klinker. We're going to continue our discussion of decision analysis today. The last session we did decision making under risk. We went out, we found out that we had our decision table, our payoff table that we had discussed. We found out that we had a probability of one state of nature occurring. Since we had two states of nature in this one, the opposite will be 1 minus p, 100% minus the probability that the other decision occurs. We found that we had linear relationships that could tell us for every value of p what the expected value of each decision was. The expected value, monetary value of a investment in small condos was going to be $8 million minus the probability that we have strong demand. Kept going and got all three of them. We plotted the three. The purple line here represented small, blue medium, green large, and we found out that we had indifference points at 0.3 and 0.7, probability of 30%. At 30% probability of strong demand, we changed from small to medium as our favorite. Between 30% and 70%, medium was our favorite. At 70%, we changed to large. We would rather, if the probability of strong demand was greater than 70%, we would prefer to invest in large condos. We put all this together, and the orange line that I've put in here, that is expected monetary value max. That is the curve that gives us the best option for every value of p. And it basically follows along with the indifference points that we found. Now the one thing you'll notice is we start at 8 million, we end at 20 million, and then it dips in the middle. That's related to that risk we're talking about. We don't know what the probability is. As that probability that we get a strong demand, the probability of strong demand, as it approaches zero, it's obvious the less chance that we have that we're going to have strong demand, the more chance we're going to have weak demand. We're going to take the best option in weak demand, which is $8 million. So as this gets closer to zero, we're getting closer to certainty. As it gets closer to 1, as it gets closer to 100% probability that we have strong demand, we're going to want to go for that large investment. We're going to go for that $20 million. It's in the middle that the value sags on us when we're under risk. Today we're going to talk about under certainty. Certainty means we know for certain what the probability of strong demand is. We don't know if it's strong or weak. We know for certain. We've done market analysis. We know for certain what that probability is. Well, how do you get certainty? How do you get a stronger feeling that you know what the probability of something is? And the bottom line is you do market research. You go out and get more information. Information costs money. If we went out and found exactly what the value of p was with 100% certainty, then we would have a linear relationship between the value here at 0% probability and at $20 million for 100% probability of strong demand. So how do we go about doing this? Well, what it means is we would have a linear relationship and we would have a line that starts here, ends here, and goes straight across like this. This line represents what we call the expected value with perfect information, EVWPI. It means perfect information means we know without a doubt what the probability is that we're going to have strong demand. And we have a linear relationship. Can we figure out an equation like we've done here? Can we figure an equation for EVWPI? Certainly. It's linear. You've done this before. What do I need for a linear equation? I need two things. I need first an intercept, a y-intercept. The intercept where the x value, the horizontal axis, is 0. My horizontal axis, again, is probability from 0 to 1 of strong demand. In this case, where it's 0 is right here, the intercept is at 8. So my equation for EVWPI, expected value with perfect information, equals 8. There's my intercept, all right? Then I need a slope. How do you get slope? Slope is rise over run. All right? So we're going to get our slope here. Well, what's the rise? I start at 8, I end at 20. So the rise here is going to be 20 minus 8. The run, I start at 0, I go up to 1. 1 minus 0 gives me 12 over 1. My slope is a positive 12. So it's going to be, EVWPI is going to be 8 plus 12p. Now, what mistakes do I see students doing here? Quite truthfully, you make a mistake, you'll end up with a negative slope because you do something backwards. You'll either start here at 8 and subtract 20 from it, and then take 1 as this, so you get minus 12 over 1. Or you'll do just the opposite. You'll go 20 minus 8 and then 0 minus 1. So how do you make sure that you do it right? Well, you're always supposed to start with the ending point and come this way. But since we're used to reading things left to right, a lot of people do it backwards. As long as you're consistent, it won't matter. If I do it backwards, what do I get? I start at 8, I subtract 20. As long as I start at the same side again, it would be 0 minus 1. I start at 8, I got to start at 0. End at 20, end at 1. Now in this case, I get a minus 12 over a minus 1, which still gives me a positive 12. So don't worry about which way it goes. As long as you stay consistent, you'll still get the right answer. Well, what does this mean? Perfect information. It means I've done research, and I now know with certainty that the probability, let's just say the probability of strong demand is 50%. If that's true, this is right around 0.5. This would actually be my expected value with perfect information. Well, what we want to know now is, what am I willing to invest to get that perfect information? This is what it is under risk. It's worth this point right here under risk. This is what it's worth if I go invest in more research and get perfect information. So what do I need to know here? What I need to know is how much I'm willing to invest, and the difference between the two, this difference right here, that's how much that information is worth to me. We call this EVPI, the expected value of perfect information. Students do get confused here. Expected value with perfect information, expected value of perfect information. The expected value with perfect information is what you would expect to get. So it's this curve here. All right? With perfect information is the curve. Expected value of perfect information is a vertical distance. It's how much I would pay at each value of p to get more information, to find out where I want to be. All right? So EVPI is vertical. Notice it's the difference between this black curve I have here, EVWPI, and this orange curve, EMV max. So EVPI is going to equal the difference between EVWPI and my maximum expected monetary value curve. All right? Well, I know what EVWPI is. It's 8 plus 12p, so I just substitute that in there. Minus EMV max. EMV max depends on where in this probability spectrum we're evaluating it. I told you to evaluate it around 0.5. Well, at 0.5, medium is our maximum monetary value, so we would use the equation for medium here, 5 plus 9p. Now we can do some algebra. 8 minus 5 is 3. 12p minus 9p is a minus 3p. So what would I pay? What's the difference between here and here? What would I pay for more information? And the bottom line is I would put that 0.5 in. I said it was going to be at 0.5. I would put 0.5 in for P. So I end up with 3. Wait a minute. Is a plus point. 12P minus 9P plus 3P. So I add that in there. That's going to be plus 1.5. I would pay up to $4.5 million for this information. Notice also, as we get closer to 0, as I said, as the probability is closer to 0, as there's less and less chance that we will have strong demand, we're not willing to pay as much money. These two values become closer and closer. We know what it is at 0. We know exactly what it is at 1. Again, it converges up here. It's out here in the middle that we need to go get more information. It's worth more information. It's worth more research for us to find out which decision we wish to make. One last thing I want to talk about before we move on from this. Notice how I keep talking about the equations in terms of what they mean. Don't think of it in terms of a letter, a set of letters. Talk yourself through it. This is the expected monetary value of an investment in small condos. Make sure you're always saying that to yourself so it's not just some equation. You understand what it means. And it equals $8 million minus the probability that I have strong demand. If probability is 0.1, I'm in this range. $8 million minus 0.1, 8 minus 0.1 is 7.9. At a 10% probability of strong demand, this investment is worth $7.9 million. Make sure you're thinking it through. EVWPI, this is $4.5 million. It's not just 4.5. We'll move on with another way to solve this in the next video.